All right. I
Um,
guess I will introduce Billy, the master of metauni code, uh, back with yet another extravaganza of interesting stuff.
Thanks. Let me just paste in a little link if you'd like to join the audience um, of the place I'm doing the talk. I'll put it in the code channel as well, just in case someone sees it there. You don't. It's probably better to just watch on my screen, which I'll share now,
Mm-hmm.
because I'm going to flick to other things. Um, but yeah, just join my live stream and you can watch the talk from here. Some growing screen here. I've got my iPad here as well. Um, okay, so I don't have the title here. I did have a title slide, but I decided to remove it in favor of uh, keeping two of the slides together that I wanted to be together. So I'll just have to tell you the uh, title out loud is Temporal Game State for Reactive UI. And so I I need to explain to you like I guess what I mean by temporal. That will come up a bit later. But for now, I think it makes sense first to for me to try and set the scene of what Roblox is. And yeah, maybe you're experienced with Roblox, maybe you're not. But let me just set the scene. So Roblox at the center of it is essentially this data model. I guess most frameworks have some kind of data model. Like on the web, you have the DOM. I already forget what that means, but sort of corresponds to like the HTML components that make up the web page. But in Roblox, there is a similar sort of tree of things, but it consists of instances. Here, I've just got a sort of abstract uh, representation of the data model, what it looks like, because when I tried to include the image in the slide, Roblox didn't like it. They tried to moderate me out of doing it. So I can flick over just to show you what the data model looks like in this example project. It's this sort of explorer thing on the left, and it consists of a workspace containing, well, I guess here's what the workspace looks like, and having an instance in the workspace uh, makes it become part of the 3D environment here. And then you have these other sort of containers like replicated storage. That's the sort of common ground between the server and the client. That usually people put scripts there, and you have some sort of server only locations as well, and some client only script locations. So that's what the data model looks like. Uh, so let me come back to here. And here I've sort of made a list of ways in which you can query the data model and also see events from the data model. So here's first my list of the main queries. Like I think these everything on this slide is like not all of them are used all the time by Roblox developers, but I think this is the core of interactivity between scripts and the data model. So Uh, firstly, for each instance, you can get its children. So in this hierarchy, there's uh, yeah, each instance is associated to some collection of children. They can have you can have more than one child with the same name, so it's not like like a unique mapping or anything. It's just sort of an array of children whose order is not guaranteed. But then you can also query, all right, I want exactly the child with this name, but it says first child because there's this possibility that you have more than one child instance of the same name. So within this name is sort of a hint that it's kind of uh, you're risking the possibility that you have two children of the same name, and so maybe be careful about your naming conventions. You can also query do this. I've just got an example dot query, which is I'm querying the position of some object, so that'll give you some vector3 data type. You can also here I've done a collection service call. You can get every instance that has a tag associated to it, which is just a string that you can use to sort of, you tag things in random different places in your workspace, and they get they all get sort of collected when you call get tagged. I guess this should have a tag name call in here as one of the arguments. And finally, you can get all the players that are currently in the data model. But the thing here is that these are all snapshots, and in order to have any kind of interesting behavior and behavior that continues to work, or even to just respond to things happening, you need to make use of events. So here's all the main events that you make use of. I guess the main one I see being made use of is I guess actually what I've missed here is remote, like some remote event, and then you like fire the server. And I guess that this is the sort of main essential event that or signal that you need to use in order to drive game behavior, especially between the client and server. And a lot of these other ones, you can kind of get away with, instead of binding to the data model, just sort of have a virtual version of it in your script memory, and then just like have all the behavior sort of on the virtual side, and then things just happen to the things in the data model as a result of that. Which I think is a sort of, I think it's kind of a trap to do it that way, because I guess you're sort of led to do that because of some shortcomings of being able to query this data model and attach signals to it. But yeah, I'm sort of proposing a better way to do that. So just to do the most bare metal thing, you can connect to different events of instances. So I think these first three here are given some instance, like a part object. You can ask it to sort of let you know when a child is added to that instance. So and when you connect to all of these, you connect some kind of callback function. And that function is called with maybe some relevant arguments, like the function might be Roblox will pass in the child's instance that was added and let you respond to that in any way you like. Next one is it can tell you when something is destroyed, which is this is a really important signal, which is there's usually some layer of abstraction over it that actually binds to that event, but you can directly just bind to the destroying event. You have get property change signal. So this one corresponds to this position call. So you can query the position at exactly one time, or you can bind to get property change signal, which will give you a signal. You pass in. I've done a bad job here because you actually pass in the name of that property. and then you bind it, like it gives you the signal, and then you bind to the callback for that property. And so whenever that property changes, it will let you know, and you can run some behavior from there.
Well,
I
so
guess position is a bad example because uh, the physics engine does not the physics engine updates like at 120 hertz, but Roblox runs at like 30 or 60, or maybe it's. I think the physics it runs at like 240 hertz. It's just too quick for it to be a good idea to bind to
mhm.
the position changed event. Um, but there's many other properties that you might want to bind to, which we'll see more of. And then you have finally there's these collection service signals for seeing when some tag gets added to an instance or is removed from an instance. And the same with seeing if a player has been added, or there's also a removed signal for players. And finally, I've got the sort of touched event. So for when you're if some part touches some other part, like the player touches some platform, you can respond to that. Does that all make sense? That's kind of a picture of what Roblox is and how it works. Any questions so far? Okay, cool. So there is a problem here that is maybe more obvious once you've had some experience developing in Roblox, which is okay. You can call a lot of these the queries and the events actually you have to call them on an instance. So the instance is associated to sorry the the signals themselves, they don't exist statically. You have to have the actual instance in existence to bind to one of these signals. That's not true for these collection service ones, but it is true for uh, like most of these other ones, like destroying and child added and get children, find best child, everything. And so that introduces a problem. Let me just move it slide here. Okay, so the way this problem is usually addressed, and I guess this is sort of one of those things where I think at one time I would have had a better explanation for how it's usually addressed, but because I've been uh, soaking my brain in RX, this library I've been using, I'm sort of less aware of the usual approach to it because it mostly doesn't make sense if I do it any other way. But let me try and reattempt what the usual approach is. So here, like I've got the client and the server. They both have their own copies of the data model, and there is replication in this direction. So things that happen on the things that are changed in the data model by the server are replicated to the client. There's some replication in the other direction, like the client has ownership over its own character model, but for the most part, it's replication in that direction. So usually, all right. So here's one common scenario is okay. You have a lot of behavior you want to bind to the character of a player, but often the character doesn't. Like so, the player will join the game, but the character, which is the sort of physical model of representing that player that lives in the workspace, that doesn't instantly exist once the player enters. There's some amount of delay before the character is created, and not only that, the children instances of the model that make up the character. There's no real guarantees as to when they come into existence, and yeah, in what order. Like, I think that there might be some rules, and like if you're an experienced developer or you've read some like forum posts that some uh, staff member at Roblox like told you, oh, it's always the case that the if the humanoid exists, then the head and the feet exist, or something like that. Um, I I think it's the benefits of the RX approach is that you essentially ignore all assumptions about the order at which things exist. Um, and so uh, the other sort of solution to this that isn't sort of order agnostic is okay, you have some module, something in the script world, which sort of owns the character, or it's some like sort of interface abstracting over the character, or it might be some other entity like you could have, or for example, Metaboard. Yeah, Metaboard kind of does this, I guess. There's a setup phase, which is all right. I'm trying to make things exist, but it's going to take a little while. Um, and I'm not going to make myself like other modules might want to sort of make use of one of those metaboards in the data model, but I'm just kind of I've got some like table containing metaboards here, um, and I'm not going to make this metaboard available until it's sort of initialized and everything exists. And then once everything exists, you can bind to the remote events, or if there's some state object inside it, then you can sort of connect to that. And then yeah, once everything exists, then you're good to go. That's the usual idea, and so it sort of points to all right, the data model itself and those query events, those queries and signals themselves aren't really enough for the data model to be your source of truth. You sort of always want to use some abstraction between your modules. Um, yeah, and so let me sort of propose a way of getting around that by first, or let's look at an example of what usually happens uh, just when you're trying to implement some behavior. So I've got some example behavior here. Uh, and sorry, are there any questions before I proceed any further? Okay. Okay. So you might have noticed when my character moves around, uh, when he stops, he always looks at the camera. This was actually probably the first thing I did with using RX. And so I want to sort of let's look at how like the first way you'd think of doing it, which is all right. You this so the spec is the speaker should face the audience when they aren't moving. Um, and yeah, okay. So here's one solution. You get the speaker from the orb, because orbs uh, have some dedicated speaker, and so I'm using a sort of this is an object value, and it either contains nil or it contains a player object. And then you get the character from the player object, as in the speaker. Um, or you do this little trick where okay, the character might not exist, so you wait for the character added event to fire, and that will give you the actual character object back. Um, and then we want to get the root part because we want to rotate the character. But that might not exist yet either. I've sort of left implicit when this code is running, but it's sort of, I guess it runs at the start or something. And then we have, we're just frequently querying the data model with the heartbeat method, which is literally every single frame do something. And what are we doing? We get the humanoid object, which is kind of the character controller and animator object, which is a child of the character. But it might not be there. So we're gonna, every time it's not there, we just sort of exit early. And so if the character exists and humanoid.moveDirection.magnitude is 0, so this is how we're sort of telling that that they're not moving. Then we want to like change the coordinate frame of the root part. And so can anyone, like, there's a lot wrong with this, but can anyone explain some problems with this implementation and why it fails to meet the spec?
I guess if they reset their character, there's going to be a problem, depending where this is running.
Yeah. So the character object might have existed the first time, and then when they reset the character, the new character object is created, and that's not stored in this variable. So this will just always be false. Or it actually, even worse, it might be true because you have a reference to it, so it won't be garbage collected. But it won't be in the data model. It's just kind of this dead reference to an instance.
Mm-hmm.
Any other ideas? Just assume this is running statically and startup on the server.
I'm not sure.
Okay, well, here we grab the speaker from the speaker value object.
Oh, right.
But when you first join the world, there's nothing is bound to that value because the speaker hasn't attached to the orb yet. So this is a point that should be reactive to changes to this value, but it's not. We're just getting the speaker. Then we have the same with the character. Okay, we remedied that, but this will just yield forever because this will error because the speaker might just be nil. So we've got a problem there. This usage of heartbeat is kind of completely unnecessary because I guess maybe this isn't too expensive. I wouldn't advise doing too much querying every single frame, like with find first child. But we really only need to check. We only care about when the move direction is 0. So why are we connecting to the heartbeat object? Well, okay, let's think about connecting to the humanoid object and getting the move direction sort of property change signal. Okay, well, the humanoid might not exist yet either. And so so we could sort of invert this, connect to a different signal that's the humanoid, but we first have to wait for the humanoid to exist. So this would have to be sort of come out here and be a wait for child instead of a find first child. But then there's actually, so that kind of fixes that, but there's a third problem, which is here I'm doing orb.position, but the orb is moving. So I guess that's really why you would do the heartbeat signal. I guess actually that would with if you change to checking when the move direction was 0.
We lost
But
the
what if
stream, Billy.
pardon?
We lost the
Oh,
stream.
did it?
Yeah.
Oh, okay. My screen went to sleep. I think it's because it's not plugged in for me.
Oh, good.
Let me plug into power. There I am. Okay, am I back?
Yep.
Okay. Yeah, so using the heartbeat method where we run this code every frame, that the orb position might be is always correct because we're just calling it every frame anyway. But say if we change to just checking when the move direction changes, well then if somehow we're moving but the orb position is moving, sorry, we're standing still but the orb position is moving, we won't react to that. So this is a common scenario where not only are we struggling to connect to the move direction event because the sort of object it depends on doesn't exist yet, we also have multiple reasons to update the sort of the respond to a change. So it's not just it's not always as simple as there is one possible like event to listen to, and you only need to make updates when that one event fires. Sometimes there's like multiple sources of signals which each, when they change, you want to sort of update depending on that. So, oh yeah, and there's actually a third problem. So suppose we took care of all that. I think you could have enough like parallel connections to signals that all kind of do this same update behavior. If you're not careful, you will create a bunch of signal connections when you do connect, and you won't be garbage collecting them, which is a problem. It's good if you create these connections to signals and then just let them remain attached, they're not always garbage collected, so you might just end up leaking memory. So basically what this ends up meaning is you either don't make your like code as reactive to possible changes as it needs to be, or you do that and you can't be bothered to you simply don't have the capacity to get the garbage collection behavior.
He's talking about me now.
No, well, I do this myself. I get halfway there, and I garbage collect some things, but I'll often just like cut a corner and make the behavior a bit simpler in order to make sure that I'm garbage collection make sure I'm doing my memory management properly. Okay, so how do we fix this? So the idea is we make use of observable streams. So here is a sort of sequence of streams that is essentially all just a transformation of the top stream. So we have like a source value, which is okay, this speaker value object has some player object in it, and let's just assume for now that speaker value always exists. So we can just like statically bind to this value changed signal. And here along this time, this is time moving forward, and we have two events firing. This first one, this dot, is when the speaker attaches to the orb, so they get assigned to this value. This value object is assigned to their player object. And here, like the character probably does exist because they walked over to the orb, and in that time, their character probably came into existence. But in the abstract, maybe this character object like might not have existed yet, so we couldn't yet get its humanoid yet, or like bind to the move direction signal. So here we have the signal for the character object of the speaker exists, and it fires here when the character comes into existence. And let's say, for example, that the humanoid then is already parented to the character object. So, oh, sorry. Again, this is actually just the humanoid signal exists. That's why this sort of line begins here. And then here is when it fires because the humanoid has come into existence. And then we can instantly...
The humanoid signal, what do you mean?
I mean I guess this is actually kind of a find first child sort of thing, but it's, I guess what I actually mean is the child added signal with some logic that checks whether it has the name humanoid and it has the humanoid class.
That's really the kind of... So the beginning of the line sort of means that once you have character, it's possible to actually write down this code, which is like find first child humanoid or something, but it may not return a non-nil value until that yellow dot. Is that what you mean?
Yeah. So we like what we could, So this is an observable stream that you can combine queries and events. So we could query to see if the humanoid exists straight away, and if it did, then you could have some fire right there. But you also connect to the sort of child added or child removed events to fire more things. So then here we're binding to the move direction property of the humanoid object, and then here we're transforming that stream into, instead it fires the sort of magnitude of that humanoid of that move direction vector. So this is sort of an abstract view of like how I think about observable streams. And yeah, so the idea is we want to be able to describe this transformation from here to here without needing all these intermediate objects to exist. And you can do that with observables. And we'll go have a look at that now. So here are all of the operators. I have I don't use all of these. Basically, switch map, combine latest, and these RxI operators are the main ones that I use. But actually, I think it's more instructive if I just show you some code now. So let me go to this demo script. Let me just do a little basics of RX. So I think of RX as basically maybe an infinite for loop or a time, like a for loop through time. So here is
That
a
really doesn't help, but okay.
yeah, okay. It'll make sense when you see more. Okay, so here is just a non temporal usage of RX, which is just I create this stream that has these are like different events happening in this stream, and they contain some object, which is I've just got the numbers 1, 2, 3, 4, and then I'm going to assign I'm going to subscribe a callback to this. So here, if I do print x, and I just run this code, you can see it prints out 1, 2, 3, 4, and that basically happens because this of method just makes an observable that fires all of its arguments straight away. So that this is essentially equivalent to a for loop of for I equals 1 to 4. Do print x. It's the same as that.
Print I, maybe.
Print I, yeah. Yeah, so these do the same thing. But what you can't do with this is make it infinite in this sense. If I do rx.timer, I give it an initial delay of 0 seconds, and I make it fire every 1 second. This is an observable which emits an output every n seconds, where n is the input. And it just counts 1, 2, 3, 4, 5, and so on. So if let me clear this. If I run this, there's this observable stream coming into like that we're subscribing to, and whenever it fires, or it fires our subscription callback and prints out the value. Does that make sense?
Mm-hmm.
So you can do both. You can fire immediately, or you can implement some kind of delay and fire later on. This was actually a bad idea to run this here because I have no idea how to stop it. But I guess it's not too complicated how this works. There's some asserts, but it creates a new observable that takes in our subscription, which is a wrapper around our callback that we passed in.
Yeah, so it's the code I would have written if you'd asked me to do that, basically.
Yeah, so it has some interval loop that this is it's going to spawn some coroutine that will run forever and does a task.wait for the number of seconds, and it fires the subscription with the argument. That's how that works. Something else we can do. Actually, I need to now close and reopen this because I don't know how to make it stop. Next time I'll just run the place. Okay, and so the way that we usually you can see the kind of control is inverted, in that instead of the sort of behavior making calls to, like, instead of the behavior owning the object that it is operating on, like doing a for loop over something. We create the streams and then we subscribe callbacks to them. Let me continue with. I want to explain transformers. So the transformer is, for example, we have the map transformer, which you can. We're piping this observable into a bunch of transformers. So we have an array of transformers. Here we've just got one of them. And this is the map transformer, and we can essentially make it increment the value, I guess. Let me just switch this back to just doing just send in 1 2 3 4. So if I print that out, it does 2 3 4 5. If I repeat that, it does 3 4 5 6, as you might expect. But I can also transform in different ways. I can do a let's do instead of map, we're going to do the where transformer, which takes in an observable, and this function here is actually instead going to be it acts like a filter. So if I do math fmod x2 equals 0, this is true if and only if the remainder when you divide by 2 is 0. So it's only going to pass through the even numbers, so 2 and 4, and then it's going to apply the map to them. So here it prints out 3 and 5, because that's 2 and 4 plus 1. Any questions so far?
Nope.
Okay, the final one I want to show is called switch map. How will we do this? Okay, let's make this a timer again, and just spit something out every second. And let's say, depending on the value here, we want to we make an observation, and then we want to we create an observable stream based on what we receive, and I want to pass the elements of that observable stream to the subscription. Let me just show you how that works. So I take in my value, and I want it to print out, let's do x squared, let's just do x plus 1, x plus 2. And let's see what that does. So here it does 0 1 2 1 2 3 2 3 4 3 4 5, and so on, and that'll continue forever.
So to understand this, so the stream is then sort of, I see. So I have in my mind like a stream of events, and then each one of those events gets replaced itself by a stream, and then it's that finite stream that's processed.
Yeah. So the funny thing is, it can actually be an infinite stream as well. But there's some great diagrams I can show you now. Okay, here is switch map. They're just calling it switch here. I don't know, there's just inconsistent naming, but whatever. So here's our timer stream. And each of these diagonal streams are like my finite
Yep.
consequential stream. And you can see here that these diagrams should be read as transformations from the top thing to the bottom thing. So here you can see we emit A and B because they're coming out of the first stream, but then it gets replaced right here. And so we don't see this C because now we're listening to this stream.
Sorry, they're replaced. I don't understand.
Pardon?
Could you go back to the code? I didn't follow why there was a replace happening.
Wait. What? So here, what happens here is that these are actually all fired instantly. So they don't sort of occur across time as these ones do.
Mm-hmm.
But say, for example, let me close this. Would remind me to hit play next time instead of paste.
Sure. Yeah, it was too late.
So. Here, let's say, let's just emit X. Oh, not that. Every zero, after a delay of 0 seconds, every 0.1 seconds. So let's make it 3. I could just emit that, but let me make it more obvious by I'm going to transform that stream with map, let's say. And I'm just going to ignore the input and just return X because I have X here. So I'm making a stream that returns X every 0.3 seconds.
Mm-hmm.
So the infinite one, diagonal one, is every 0.3 seconds it spits out X, and we're changing to a new stream that spits out a different X every time we move along here.
I see.
So yeah, 1, 2, 8. It's printing out each number 4 times.
Okay.
3 or 4 times.
Mm.
And so the switch map operator is taking care of the sort of subscribing and unsubscribing from the observables.
Yeah, I get it. I've done this pattern by hand many times, I guess, using various tricks. Yeah. Mm.
Yeah. So I guess that this is a composition of other ones. So switch all. So this just takes the map part out of it.
I see.
Yeah, okay, I'm not really prepared to explain this, but I think the diagram kind of explains what's happening.
Mm-hmm.
But what we can do with this, what this switch map should, I don't know, if you're really switched on, you might be able to notice that we can use that for this. So once we have a speaker object, we can connect to the character property of that player speaker object. We can fire it immediately. Actually, what we do is we fire it immediately, even if it's nil, because we want to know that it's nil. So we fire whatever value is at speaker.character, and then we connect to the property change signal with the character property name. And whenever it changes, that's what we fire. So there's so these are the these layers here could actually be sort of one of those diagonal branches off the top observable stream. So actually, if I look at RXI.
So can I just check I have the right mental model for this? So when I have switch map, it's essentially a way of looking at all the descendants that are subscribed and kind of resubscribing them to something else higher up the stack.
What do you mean by descendants?
Well, the things that are, the things receiving, the things that are subscribed at the bottom of that, the thing that was printing X.
Yeah.
So if you go back to the code you were writing, it's a demo, yeah. So that function there, I can think of it as subscribing to this. Yeah, maybe I don't quite get it. Yeah.
By the way, this is I can get rid of the pipe. I don't know if this helps, but this operator, you apply it to this. That's what it does. So the switch map takes in this observable stream,
and
it has this callback. Let's see if we can figure it out. There's a map going on that we haven't. So let's say we've already mapped the observable. So this is our source observable. This is the timer. That's actually emitting observable streams because we've mapped it. Right? Okay, we make an outer made. These are sort of for garbage collection for our subscriptions. And we subscribe to the source observable, and this is the function we call whenever that fires. So it's going to emit one of our inner observables, which is this thing. We take that, we subscribe to it, and this. Don't worry about the other ones. We just care about fire.
Yeah.
The fail and complete are a different thing. So yeah, we just connect to it, and there should be a point where when this source observable emits a new thing, we should destroy the subscription, which I'm trying to figure out where that happens. Ensure inner subscription is disconnected first. Oh, sorry.
So this function inside the source subscribe, this is fired every time that source returns a new observable, right? So you expect it to be basically disconnecting something also, in addition to connecting.
Yeah. Inside complete equals false. Current inside equals observable.
Yeah, it's okay. I don't want to get you bogged down in this. I think I kind of get it. Yeah.
There should be some kind of cleanup of whenever a new subscription comes in. This observable, this inner sub, could get destroyed. But maybe I don't quite understand why it doesn't. Okay, so basically that is used to do this property transformer. You switch map, you take in your instance. If the instance doesn't exist, then you return a nil observation. So it just fires once with the value nil. Otherwise, you return an observable, which okay, it checks it actually has that property, as like that class has that property.
I see.
Otherwise it fires and then completes. Otherwise you connect to the property change signal, and you also fire it instantly with whatever property it has right now. A similar thing is true with find first child. So you take the instance, they've got this update current function. Whenever the child added fires, you also want to connect to the get properties change signal of the name, because that name might change, and then the find first child is now different. So yeah, all of this is the boilerplate that you will never bother to write. That connects to all of these things that come in and out of existence, or in and out of relevance. And it takes care of all that boilerplate for you, which I exploit that liberally. Okay, let me get back on track. We'll go for another half hour, but I'll see how much we can get through. Okay, I showed you most of these operators. So the story with these RxI operators, I can essentially observe any. I can connect to a deeply nested signal, which is the child of a child of a child, and like is the property of that object or something. By declaratively saying where will that thing be in the data model. So it's the head of the character of this player, and maybe the player object depends on something else. Which being able to describe some signal that will be changing dynamically and have all of that cleanup logic done for me is a really powerful way of being able to query the data model, because it essentially makes these things which come in and out of existence available statically.
Yes, as you said, this is the only sane way to do it.
Yeah. Finally, I make use of combine latest, which essentially is what I was talking about with you might have multiple sources of changes which you want to then influence the behavior. So for example, when I move around, it's not only when my character stops, but also if I made the orb move by whatever means. So for example, if I change from single board to double board, I don't know if you pay close attention, he kind of turns a little bit. And I did not even think it did not occur to me at any point that when this button is clicked, I should fire this behavior where the player then turns to where the orb is now. Like, that is simply something that arised out of me defining declaratively all of the necessary sources of input to this behavior, and then this just naturally happens as okay, of course, the position of the orb changed, so I gotta that then triggers an update. And so I do that using combine latest, which essentially allows you to take multiple streams and just get the latest value from all of them. So there's another really good picture for this. This website, RX Marbles, is actually kind of amazing because these are interactive diagrams.
Oh, wow.
So our operator in my version of RX doesn't take a callback. uh, it just gives you back a table with the values. So here they're using a string concatenation. So here you start, the first stream emits 1, and then when the second stream emits A, you get 1A. Then the first stream emits a 2, and now you have 2A. So you sort of slice along all of these observables you have up here,
I see.
and then take the most recent value of all of them. And this is essentially all of my code is just combine latest. I don't know if there's a more intelligent way to do, or like a fancier way to do some of the things that I do, but combine latest pretty much works for almost all my use cases. So we might as well look at some examples. Okay, well here is, let me, I'm gonna pull in just this code. We can run this in our demo script. Okay, so here is, I'm just sort of doing my observables one at a time. Observe local player stopped. So I take the local player and I pipe in a bunch of transformers to it. So I get the character, the humanoid of that character, the move direction of that humanoid. Not nil is actually a bad idea.
Is that like an if statement, basically? Or what's that doing there?
So essentially, if anything along here, if the observable so far is nil, nil is just propagated through. So if there was no character, then this observable emits nil, and so does this one. And so here I just need to do walk speed of magnitude equals 0.
I see.
Yeah. Okay, actually, forget about this. It's more instructive if I just don't filter it, and we'll just see everything. So I'm observing that the local player has stopped. And here's my combine latest thing. I used an underscore because I'm not actually going to query what comes out of this. Oh, actually, I am now. Sorry. This is move direction. Comes from observe local player stopped. Then I want the head object, which comes from the character. And then I can do find first child with class. That also allows me to make sure it's the right class.
Okay.
Then when you subscribe to it, you get a data table where the keys are the same keys, but instead of observable streams, you get the latest value.
I see.
So here I'm just making an explosion object, putting it at the head position, and then after 3 seconds I destroy it. So you can see it fired immediately as soon as all those observable streams emitted a single value. We got that. Actually, let me just see how many times it fired, because it might fire multiple times at the start. Alright, it fired 5 times. I think because sort of that's telling you that like the local player wasn't there. Maybe the local player existed straight away, but the character didn't exist straight away. So every time something changes, it propagates a new thing through.
So if you put that not nil thing back, it would just fire once, probably?
Actually, I can do better. I can do distinct. And that makes sure if you have adjacent emissions from your observable stream, it only emits the next one if it's different to the last one. Oh, okay, so 4 times. Okay. So I guess we also had this here. Maybe distinct. I guess at 3 times though. Yeah, I don't know. This is, to me, this is just like the character object is spooky and does some weird stuff. Like
Okay.
I really don't understand what it's doing half the time, and what uh when I was implementing the ghosts, I was uh there was some weird behavior. Um oh, but I should actually do this demo. Oh my god. Oh, okay, I get why it's firing so many times. Because we have the move direction. Every time it changes, this fires. So let's go if data.head and data.move direction. I think it actually does make sense if it's not nil, but okay, I'll leave it how it is. Dot magnitude. So now we stop, there's an explosion. And of course when we reset the character, still works. Okay, I want to talk about, is there any more questions about that?
Not from me.
Okay, cool. Where's my slide? Yeah. Okay, so now we're sort of more transitioning into how I use RX for metauni. So here's my approach to state replication between the client and the server. Essentially, I try to use value objects as much as possible for server state. So actually the orb object, how do I get the console up? Do workspace.orb get children. Do print child. Okay, so these are all the children of the orb. It has a waypoint, which is a position, a C-frame value, I think. The orb mode is a string value. Like almost all of these are kind of object values. There's 2 proximity prems there, but these essentially communicate the orb state to all of the clients. So it essentially works like this. We have the server puts a bunch of object values here, and then both the server and the client observes them. So you have the same value replicated down here. And again, this replication happens automatically. And then I have remote events. The client, if the client wants to interact, like for example, if I choose which board I want to connect to, or how many boards I want to see, this is just firing an event to the server that tells it to update this object, and it will do so, and then both the client and the server will react to any changes to that object that they are sensitive to. And so the philosophy is that, so the data model is already there, and if you have this ability to read the data model better, it's easier. Maybe it's not easier. I think it's at least more reliable than creating interfaces between modules, because
Yeah.
when you create interfaces between modules, you sort of set up contracts that that you have to adhere to, or I think most of the time especially when you're developing for the first time, you don't adhere to those contracts. And so the process of knowing how to get a value and how to react to changes to that value sort of depends on from like it depends between modules how that's implemented, and you kind of just have to check the code every time, and I guess you're liable to bugs happening with that not being implemented correctly. So I think in the long run, it makes more sense to use the data model as a source of truth. And a benefit from this is that you don't have to have one of these modules as sort of owning the state. And so what I actually do is I often have like two very closely, like I have two different server script files that both observe the same value. One of them creates the value, and so in theory I could sort of pass that object value between those scripts. But instead of doing that, I just observe it directly from the data model again. Okay, I'm just deciding what to talk about now. So I guess these last two slides are basically how I take RX and I plug it into Fusion. So Fusion is just a instance management library. So RX just observes instances, but Fusion is for dynamically creating and updating instances based on reactive values. So it has its own like reactive values, which are just using this capital value keyword. And you can assign properties, like can either just be a regular property value like the string for the name button, or it can be a value object, which in this case it's going to have the value true first for the visible property of this text button. But if I set the show value to something else, that will automatically update. And Fusion takes care of garbage collection and everything else. I could explain why. So here I'm just explaining how I can take an observable and just turn it into one of those value objects, which I believe Quenty, who gets the credit for sort of introducing RX into Roblox, has his own UI framework that allows you to just directly attach observable streams to properties of an instance. But I'm just sort of gluing RX and Fusion together to achieve the same thing. I won't actually go in depth with this because I want to look at some of my Orb code to show you a sort of real world example of what I've been doing. So here's an example. Here is my RX combined latest call. So here I have 4 observables. The first one is the speaker position. And so I observe the speaker, which, let's check how I did that. I took the speaker value object, which is an object value called speaker parented to the orb. And then I transform it to get the value of that speaker value object. So this will just observe the speaker, or it'll be nil. And then I get the character of that speaker, I get the primary part, and then I made this throttled movement observable, which essentially emits the position of this part every half second. Yeah, this is one of the powerful things about. I really like using these throttled transformers because it's something that, like, I would say what happens here is an expensive calculation that I'm subscribing to, and so to make it like correct all the time, maybe I would want to like do like an connect to the heartbeat signal and just run some check the speaker position every single frame, but that will be too expensive. So instead, I just query the speaker position every half second, like this. I also get the view mode, which is I forget what view mode is, but it basically informs where I decide to put the orb. That's another sort of state value. And then I also have this speaker attachment signal. So yeah, you can take this as just a regular. This is a regular Roblox event, checking the ancestry changed of an instance, and you can just convert it into an observable stream. And I do this because the orb is actually physics controlled and it's not anchored. And okay, so this speaker attachment is a physics attachment, which the orb there's a physics constraint attaching that to the speaker. But because the speaker is like coming in and out of existence,
I see. Yeah.
I'm like, yeah, we don't want to ever drop the orb. So this fires whenever that fires, and that might force me to change some values. And then here I just do all my logic. I have all of my game state, where the speaker position is, what the view mode is, whether it's waypoint only mode, and then I just decide what to do using that information. Let me find another example. I have. This should be. Okay, this is viewport size. What does this one do? This one should have more comments. I think this is deciding where the camera should go. So again, I have a combined latest based on what are the 2 points of interest, where is the speaker character. Oh, like I need the speaker character object for some reason. The view mode. Here I'm getting the viewport size because check this out. If I make the viewport smaller or larger.
Oh, now you're showing off. Okay.
And because if I did this with heartbeat, it would be it would be a laggy nightmare. Like it would
Yeah.
just be jittering so much. Um, so yeah, I'm achieving that there by uh, throttling it every 5 seconds and then
Mm.
getting the viewport size.
Mm.
Um, uh, oh yeah, that's the viewport size of the cam object. Um, so yeah, all of my code is just a bunch of combined lattices where I enter, I declare what context I want to be inside,
Mm.
and then I implement some behavior based on those values.
Mm. This is a very functional programming approach to uh, game construction, I have to say.
Yeah. So what makes you? Could you dive into that a bit? What makes you say?
Yeah, so, I mean, actually, I think the original motivation for the development of Clojure is obviously not for games, but it was for broadcasting, actually, for managing video streams and multimedia streams and processing them. And so there's a lot of stream processing as part of the basic motivating problem space for the design of functional programming languages like Clojure. And I don't know where RX comes from, but I wouldn't be surprised if its roots are actually in that story. So this idea of like setting up things as transformations and streams and processing them via functions is very much why functional programming became so resurgent about 10 years ago.
Mm. Mm. Yeah, I think I. So my what I find is that I don't do a lot of like making my own observables. Like you can call you can do foo equals rx dot observable and then implement the onsubscribe method and then do that. Um, but I find, I mean, I feel like these the way I use these observable streams is in a kind of strictly atomic way, and uh, I think there are more complex ways that I could transform them. But a lot of the times, like for example, I have like if view mode equals nil or view mode equals free cam, then I just like return early. I could do some like I could do some like mapping here where I pipe in like a rx.where and then I check whether the view mode is nil or it's free cam or something and then just return straight away. And that's a very simple example of a transformation I can do up here. But I don't know. I think I try and I usually try and make this not too complicated, like do too much with like just fancy observable transformations.
Yeah, that's appreciated. It takes me some time to pass this. I guess I'll get used to it, but
Yeah. And then the idea is to like do all the make it good enough here such that you can enter some understandable environment and then
yeah.
perform an update. But yeah, just what you were saying reminded me that so RX means reactive X, which is a sort of multi-language library. So you can see there's all these languages that have implementations of it, and so the documentation is quite extensive, but also like talks about the fact that the implementations are quite different, or can be different in different languages, maybe just the namings of things. But there is so much more than what I use, as you can see. There's this whole notion of hot and cold observables, which I really have no idea about. I don't even use the onCompleted or onError observables. Essentially, I just do enough such that I can the Roblox data model is event driven, I just think of the data model as this sort of complex, living, breathing entity that changes over time, rather than the other model. Uh, the other approach to programming in Roblox is to uh, wait for things to exist and then sort of hope they uh, only sort of implement behavior once everything is in existence. And when things go out of existence, you want to kind of destroy, like do sort of tear down logic. When it comes into existence, then you do your setup logic, but in a sort of non fine grained approach. Whereas I think this is more fine grained. Um, well, yeah, I guess I should probably stop there. But are there any more questions?
Yeah, thanks, Billy. That was much appreciated. I was a bit scared of this, actually. So I definitely needed this talk. I'm prepared now to understand, I think, what's going on there.
Mm. Do you, I hope it's clear that maybe I could have gone into this more, but it is. I feel I feel like, and I feel similarly with Fusion, that I am able to exit the layer of abstraction at any time I like, and that I can, like,
Mm-hmm.
I'm not tied down, like, because like with Fusion I actually get the instance values back, and here when I this example of interfacing with like RX and Fusion.
Mm-hmm.
Like, if you know how this works, then you know how to take like any other sort of state management system and sort of plug RX into it. Um, yeah, I find it quite a flexible way of uh, just essentially replacing signals with observables.
Mm-hmm.
Um,
Yeah, I'm sort of
yeah,
interested in. I detect a more broad change in your attitude towards this use of the data model, obviously, which maybe feeds back to change some of the decisions in Metaboard and other places. Is that accurate, do you think?
yeah. I haven't, I haven't thought of much to change about Metaboard. I guess mostly things that I think I've got Metaboard working, so there's not really much reason. Like, I could redo it with more observable stuff, but I don't think there's much to gain in that respect unless I add new functionality. But what Quenty has said in there's a RX forum in the Roblox open source developer Discord. He says you should use RX for everything that doesn't run every frame. Like, you have your logic, which is stuff that is like bound to the heartbeat method. Don't do that with RX, but whatever sort of happens infrequently, like events that
Mm.
occur based on state changes, you can use RX for that. Um, oh, and I should give a shout out to Anonymous. That's how you say it. Uh, so I really wanted to use RX, but I don't understand the Nevermore engine. Is like Quenty's own uh, framework for that has a million libraries in it. I was sort of scared to commit to this just to get RX out of it, and Anonymous implemented a standalone version of RX. I think somewhere down here. Yeah, ripped a standalone version of Quenty's RX module out of Nevermore. Looks very promising. And so what I did is I took this GitHub gist that has Rx implemented in one file here, and that's what I used. I found one bug, and I think I suggested that change in the comments here. But I've sort of been adding to this library because it just has some simple examples. And actually, on that note, here's something else interesting. I can tell you about how I got ChatGPT to help me. What was I doing? Basically, I wanted it to help me. I was merging two observables, which, how does merge work? You take two observables, you merge the streams. Does that visually make sense?
Yeah.
And so I did that with Rx from and from signal. And what was I doing that with? This is the function I made with it. I merged the collection service get tagged. Like, I put that into the from, which is just like of, but it takes that collection and just fires all the members of this array. And then the from signal, so that whenever a new instance is added, it will fire. And so I'm just merging those streams together. So this is just my sort of this is just my observe tagged instances observable. But it wasn't working, and so I just pasted in the entire library, or just, I guess, the relevant part, because it doesn't know how. I don't think it has this GitHub gist in its training data. And we went back and forth a few times. It suggested different points where I could add like print statements. And then it suggested somewhere, it was saying make sure that they work independently of each other before it merges. Then it said this: make sure the merged observable is not completing early. So I was ignorant to what completing does, but it's basically what you have here when this observable completes. Okay, well, actually, in this implementation, in this diagram, it only completes when the last one completes. But that wasn't true in my implementation. The from observable just emits all the members and then it completes, and therefore the merge, when they merge together, that was completing early. And that's not exactly what it said, but that like made me figure that out. And then I was like,
oh my god.
and then so it told me to use rx.concat, which didn't exist. It wasn't implemented. And so I was like, can you write it? And then it did it. And all of this is like, I don't think there's any Rx implementations in Lua in its training model. And this is all using conventions from other methods in the Rx implementation, like new observable and everything. And it came up with this logic that does concatenation, which is fire from the first observable until it completes, and then go to the next observable. And so that's now in the bottom of the Rx library.
Nice.
I did read it semi-carefully. But yeah, this is credit GPT-4.
Yeah, nice. This would have felt sci-fi future a year ago. Now it's like of course this works.
Yeah,
Thanks.
this was also something that I was like, I I didn't know how to isolate the problem, like, because I didn't know where to dig into, and I was like stepping through all the internal logic, and I just had no idea. And so this was a different way of isolating the bug, is get the language model to give me ideas.